And coming up, we're talking about, on second thought, let's not go to Mars, and we're missing an opportunity. And of course, taking listener questions about all things in this beautiful universe. We record the show every Thursday at 4 p.m. Eastern. So go to our website, spaceradioshow.com, and leave a voicemail so that you can get your question on the air. And in today's Blue Shift, I'll be talking about the language of science. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, and for the next half hour, your agent to the stars. Got an exciting show for you today on Space Radio, where we talk about all the beautiful things in this universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A. That is the best studio in the world, WCBE Radio Columbus. And if you want to get your voice on the air, go to spaceradioshow.com and you can leave a voicemail directly on our website any time of the day from anywhere in the world. It is true. Get those questions in. We'll have a nice little chat. You can also follow along on our live streams on YouTube and Twitch. Go to spaceradioshow.com for the links to those, and you can tune in live with the space cadets from around the world, including but not limited to Istanbul, Turkey. Love Istanbul. Redruth, England. I suppose it's a nice town too. Moore Park, California. Lyons, Colorado. Stavanger, Norway. Battleground, Washington. Pell City, Alabama. Walthamstow, I probably mispronounced that, UK. London, UK, and Princeton, New Jersey. Send me questions there too, folks. I mean, you're basically in charge of this show, except you're not. Hey, Space Cadets, how you guys doing today? Audio's cutting out. Oh, other people are saying audio is all right, so I don't know. Audio's fine. It's just you, man. Shay Teely, it's just you. You got problems. You got to work on your own personal problems, just like Greg has to work on his own personal problems. I have a Valentine's present for you, Greg, at the end of the show. Remind me, okay? It's just for you, okay? Before I start taking questions, I did want to share some interesting bits of news I caught recently, and there's two lovely, and quite tragic, actually, Mars stories here that I wanted to bubble up for you. First, Opportunity, man. The little rover that could. Actually, it's not so little. It's like the size of a minivan. It's a pretty big rover. And yeah, it's done. It's done. Pour one out on your Martian soil because Opportunity is over. This thing, this little craft, this little dude had a mission span of like 90 days. 90 days, and it went for 15 years. It was it's supposed to explore one crater. It visited like 3 craters and a valley and then all the bits in between. It was supposed to go something like 1,000 yards or something. It ended up going 28 miles in its mission. And what finally did it in, unfortunately, was that giant dust storm over this Martian summer, where the entire planet got locked in a single cloud of dust, blocked out too much sunlight. Opportunity couldn't recharge its batteries. It couldn't use its batteries to communicate or do science. And it just never recovered from that. Since the summer, since the ending of the storm, NASA engineers and scientists have been trying to communicate it, trying to revive it, trying to get back to normal operations, but just couldn't. So they had to call it, and they pulled the plug. And I'm sorry. So a moment of silence for an opportunity that we will always miss. And speaking, a moment of science over. Now, speaking of Mars, landing on Mars is hard. It's really hard because Mars has a little bit of an atmosphere, but not much. It's like 1% the air pressure of the Earth's. And usually when we land stuff on big planets, like say the Earth, say we're bringing a spacecraft back to the Earth, we use big giant parachutes. Because we have a lot of air and there could be a lot of drag, and this slows down the thing so you don't just go splat into the ground. Now, on Mars, you don't get to do that. You have to use rockets to do that. But rockets need fuel. And if rockets need fuel. You need to bring the fuel with you to Mars, which means you need to get it up off the Earth and send it to Mars and take it with you. So that takes up weight, that takes up space, that costs money. And this is a very, very tricky engineering challenge of how do you get humans on Mars? So the heaviest thing we've sent to Mars is around 1 ton. How do you get, say, a 5 to 20 ton vehicle to Mars, which is what would be needed to send people there? Well, you need big rockets to land them, but the rockets themselves need fuel, and you can't just pack extra fuel because then you need bigger rockets to get off the Earth. It's a complicated problem. It's a very complicated problem, but we're working on it, all right? And so this, to me, just highlights one of the many engineering challenges. This is not an impossible problem. This is not something we could never solve, but it's something that we're gonna have to fix. We're gonna have to figure out if we want to send people to Mars. It's not just let's build a big rocket and there we go, we can get people to Mars. There's a whole chain of technology that needs to be developed and needs to be solved in order to get us to Mars. And then once we're there, let's hope there's no giant globe-spanning dust storms that will, kill us all like the little Opportunity rover. That's the latest and greatest when it comes to space. I didn't mean to get so melodramatic, but it's time to answer some questions. All right, Space Cadets, I've got a bunch of voicemails, but I'm only going to do a couple of the voicemails so I can get more, because I know I've been neglecting you, and you know how my heart beats for you. You know how I feel for you, so don't worry. I will get to your questions. I'll take probably 2 or 3 questions from the chat in today's show. But first, we got a voicemail. What do you think, Greg? Should it be Terry, Hunter, or Azra? Terry. He's been waiting. All right. We've got a voicemail ready to go. Remember, you can leave a voicemail at spaceradioshow.com from anywhere in the world, from at any time of day. Leave that voicemail and we'll get it on the air. And here we go from Terry. Hit the button, Greg.
Hi, Paul. Terry Crook here again. If a moving object has more mass, what is the speed associated with the object having zero mass, in the same way as removing the kinetic energy produces a absolute zero temperature?
Okay, Terry's done. A wonderful question, Terry, talking about mass, talking about relativity, talking about speed. So moving objects weigh more. This is the fundamental idea behind Terry's question. The faster you move, the more you weigh, the heavier you are. Why? Because energy is mass. Good old-fashioned E equals MC squared. Energy equals mass times the speed of light squared. Take out the speed of light. It's just a conversion factor. It's just a number floating around. The bare bones of that equation is E equals M. Energy equals mass. Mass is energy. Energy is mass. Drill that into your brain. If you have mass, you have energy. If you have energy, you have mass. They are two sides of the same coin. That means a hot cup of coffee weighs more than a cold cup of coffee. That means a baseball in your hand weighs less than a baseball when you throw it, because the thrown baseball has kinetic energy, which is what Terry was asking about. And he was asking, what's like the minimum mass? Right. If you're not moving at all, what is your mass? So it's actually, this is going to take a bit to untangle. All motion in our universe is relative. There's no such thing as absolute speed. There's no absolute reference frame. There's no set of grid lines out there that we can all compare to. No, all motion is relative. I can only tell something is moving relative to me, in comparison to me. where I look like I'm standing still and something moves across my field of view. But according to that thing that's moving, they're staying still and I'm the one that's moving. It's all relative. So if something is at rest relative to me, where I'm standing still and they're standing still and nobody's moving, then they have a certain amount of mass associated with them. Like I'm staring at Greg right now. There he is. I'm staring at Greg. He is at rest relative to me. He's not moving left, right, up, down, back, and forth. He is at rest relative to me. He has a certain amount of mass. I'm not going to ask him how much he weighs. I know he's working on it, and so we're going to keep that number pretty sensitive. So he has a certain amount of mass. This is what's called, in some circles, this is what's called rest mass or bare mass. We're just going to call it mass. The mass you have is your mass at rest. Like your mass according to you. I am at rest relative to myself. By definition, I'm not moving away from myself, although sometimes it feels like it. I'm not moving. So I have a rest mass, or I have a mass. That is the number on the scale. Now, if I were to start running, I would have some kinetic energy, and I would have more mass. But I would have more mass only relative to Greg. If he's watching me, Greg would say, oh yeah, Paul, you're getting bigger, as you run, you have a little bit more mass. All these measures are relative. So according to me, I only have my mass, but according to other observers who are watching me, my mass can get higher the more energy I have. This is a fundamental concept in relativity, that all motion is relative. What relativity does, what this theory of special relativity does, is give us the language to translate back and forth between different kinds of mass and different kinds of velocity and different reference frame, where at first it seems like this mad jumble where nothing makes sense, where everything is relative, everyone has different speeds, everyone has different masses, and it's almost like it's like a madhouse. What special relativity is the conversion book. You say, okay, if you're moving relative to this is what their masses look like, and then you can translate, okay, according to their position and their reference frame, this is how much mass they're observing and how fast they're going, what other people are doing. It's the conversion book. It's the translation between all the different reference frames in the universe. That is exactly the job of special relativity, is to provide those conversions so that it all makes sense. All observers have different numbers for many, many different things, different lengths of time, different lengths of space, different energies, different mass, all that. Special relativity is the translation between them. I'm Paul Sutter, and this is Space Radio. We got to go on break here in a little bit. This show is brought to you by you. Go to patreon.com/PMSutter to learn how you can support the show, and I will see you after the break. So you guys saying you get... Yeah, okay. Greg, we're having some audio issues. It's getting that high-pitched feedbacky thing. I can hear it in my headset. You want to hear it? You want to come back here? It's good. Thanks for the diagnosis, Space Cadets. Yeah. So it's not ending up in the recording. But as I speak, you can hear that. Woo, yeah. It's something in the thing that comes back to the thing, and when it plugs in, it
very technical.
I'm very, I could basically engineer the show. Can we fix it for this show?
I don't know. I don't want to start messing with your stuff.
Yeah, don't mess with my stuff, dude.
Is it cutting out on their end?
No, it's just getting that high. It's the exact same thing that I'm hearing in my headset. We need that little technical difficulties. Okay, we'll work on it.
Okay.
We'll work the problem, Greg.
Okay.
Thank you, Greg.
Sorry, guys.
Sorry, Greg says sorry.
I'm a loser.
I did not say that. Those words did not come from my lips. This is Greg. Quote. I'm writing it down for you, Space Cadets. This is a momentous event. Look. I am a loser. quote Greg. There it is, folks. I am a loser, says Greg. He just said it. Like on it, like everything was fine. And I was okay. Like, we're having some, wiring issues or whatever. And then on his way out, Greg's like, I'm a loser. Are you dealing with some stuff, Greg? Yeah. Oh, he's dealing with, I'm the issue. I'm the issue. Okay, that's fair. That's fair. I'll allow that. You have a lot of fans, Greg. If you love Greg, let me know. If you love Greg more than me, let me know. Because it's Valentine's Day. I need to know who loves me these days. Paul is the issue. So we're going to find out. We're going to find out if you love Greg more than me. I don't know why I asked these questions. I just hurt myself, man. I'm just hurting myself. Oh, some people love Paul and Greg. We got to vote for Greg. So you're 2-1 in favor of Greg so far. 3-1 in favor of Greg. Greg said he loves me. No. Oh, you're a loser. I'm a loser. I thought Greg was doing this. He's like, and I'm like, you love me, Greg. He's like, no, you're a loser. Greg's okay. I love it. All right, let's get some of your space gas. I'll do 3 of them. What do we got here? What is the smallest particle of matter? It can be affected by magnetism. So where light is affected by magnetism, have one have energy but not have mass. Okay, these are great questions. Okay. I do have a God complex, sorry. Greg. Oh, wow. It's actually pretty tied now. It's actually pretty tied. Don't shake your head. Man, that cut him deep. I was okay. I want to say, I want to admit for the public, this is going to be recorded on YouTube. I was okay with you winning. I was okay with it because secretly I love Greg too. Like, I was okay with it, but you're not. You really wanted to win. You really wanted to win. Okay. We're just going to let that sink in for a bit. Let's do some questions. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. Got another Space Cadet questions all lined up. Wonderful questions today. But remember, you can join the conversation. If you want your voice on the air, go to spaceradioshow.com and leave a voicemail, and we'll get you on the air, just like we did with Terry in that other segment. Now, to the Space Cadets, who are always so patient and so attentive and have so many questions and have deep affection for Greg. This is Valentine's Day, and it has become very clear that the Space Cadets who watch live love Greg very much, and I think he loves them too. It is reciprocated. There's the foundations of a beautiful relationship here. Starting off, we've got Thunderduck on YouTube. Well, what is the smallest particle of matter that can be affected by a magnetic field? So if you are feeling like you want to be affected by magnetic fields, you need electric charge. Electric charge is the key to your happiness when it comes to magnetic fields. If you have an electric charge, if you are not neutral, if you're either positive or negative, and you are moving, then a magnetic field can influence you, and it will deflect the path of your motion. It will make you go sideways, curve around. Magnetic fields are very curvy kinds of forces. And the smallest, lightest particle that can be affected by a magnetic field is the smallest, lightest particle that has electric charge, and that is its namesake, the electron. The electron is the lightest particle that has an electric charge. It's very, very tiny, 0.5 mega electron volts, if I'm remembering my physics jargon, which basically makes no sense to most of the audience. And we're going to be okay with that because we're just going to remember that electrons are really, really tiny. They do have electric charge, hence the name electron. And so they can be and are frequently affected by magnetic fields. As in the case, you remember those old cathode ray tube TVs, the big boxy ones? The picture was generated with electrons being moved by magnetic fields. Next question, we got Sam Pollard on YouTube. How can a photon have energy but not mass? You know, back in that little segment a little bit ago, I was going on and on and on about how energy is mass, mass is energy. If you have mass, you have energy. If you have energy, you have mass. I was correct. I did leave something out. The Einstein's famous equation, E equals mc squared, is not the full equation. There's another part that gets left off most of the time because it's not as punchy. It doesn't quite fit on a t-shirt. The full equation, let's see if I can do it off the top of my head. It's E squared equals m squared c to the fourth plus p squared c squared. I think I did it right. I'll say it in words so we can all get there together. Energy is mass plus momentum. That's the missing piece. Energy, total energy, equals mass plus momentum. Now, usually we leave that momentum piece off because we're trying to examine how much energy you have just by virtue of your mass. But as Sam Pollard mentioned in his question, photons don't have mass. So how can they have energy? Because they have momentum. They don't have mass, but they do move. They can hit you in the chest. They can push you a little bit. They do have momentum. And because they have momentum, they do have energy. Great question. Now, next on the list, we got Weekend Party. Call me, by the way, because I could use a party on this weekend. Weekend Party on YouTube is asking, how could a supervillain realistically destroy the sun? Now, I'm not going to give you the easiest way to destroy the sun because I suspect, Weekend Party, that you are a supervillain, and I'm not really up for aiding and abetting supervillainy on the Earth or the solar system or, quite frankly, the entire universe. It's just against my moral code. So I'm going to have to withhold some information about destroying the sun because I don't want to give you that knowledge and then you go do the thing to destroy the sun, because I don't know about you, but I'm a big fan of the sun. I think it's great. It's wonderful to have the sun in our lives, and we should probably not destroy it. But there are a lot of ways to destroy a star. All of them require massive amounts of energy. All of them require massive amounts of energy. The easiest way to destroy a star is to wait. Stars eventually destroy themselves because they run out of energy. They can't keep producing fusion reactions in their core to maintain the equilibrium necessary to sustain themselves, and they usually end up blowing themselves up in the process. So if you want to destroy a star, just go get a coffee or something. You know, just chill out for a while, a few billion years or whatever, but eventually the star will destroy itself. Another way to destroy a star is to pick it apart. One by one, just reaching in like bucketfuls of plasma, get that hydrogen, helium, chuck it out into the outskirts of the solar system and just dismantle the star. That requires a tremendous amount of energy, as you might imagine. More energy. I remember doing this calculation once, and I forget the results. I believe if you want to disassemble the sun, it takes more energy than the sun will produce in its lifetime, but I may not be correct on that. Another way is to seed the star with a bunch of heavy elements so that they sink into the core and disrupt the fusion process. Now, again, this is not going to be an instantaneous thing. In fact, by the way, you could shut off the core of the sun. Like, you could just snap your fingers in the core of the sun, all the nuclear reactions in the sun would shut off. And it would take somewhere around 100,000 years before the surface of the sun would start to change, before the changes that you wrought in the core would propagate out to the surface. So, again, if you're going to try to destroy the star either by disrupting fusion reactions or accelerating them, it's still going to be a waiting game. Like, stars are very, very stable things. They're just really, really good at being stars. And it's hard. They got their game going on pretty good. And it's hard to shake them loose from that. We got another question on YouTube. I'm doing lots of YouTube questions. This is great. From Dominic Wally on YouTube. How can we know in advance that we won't land in a dust bowl on Mars that eats our lander or rover? This is a wonderful question. The answer is we don't. It is so hard to predict these Martian dust storms, especially the giant ones that span the globe. They happen every few years or so. And in fact, during the dust storm that happened this summer, NASA's InSight mission was on its way to the red planet, and we were starting to get a little bit nervous. There was a little bit of nail biting going on, a little bit of gnashing of teeth, that by the time InSight got to Mars, the dust storm would still be happening, and it might screw up the landing. Now, InSight itself is not solar powered, it's nuclear powered, so it's all good. But like, it could have messed up the landing. It could have, it couldn't do its guidance sensors. It couldn't map out the terrain. We were seriously worried. Thankfully, the dust storm cleared. InSight landed just fine and has continued its science mission ever since. But it's a crapshoot. You don't know. You gotta roll the die. I mean, space. Man, you think Earth is hard and nature is random on Earth? Just wait till you get to space. All right, it's like next level difficulty. It is advanced man versus nature. Like Earth, surface of the Earth, this is level 1. This is the beginner level. This is where we have air and water and everything we need to survive. We just gotta fight a bit for it. You get out in space, you got nothing. And yeah, you got nothing. Happy Valentine's Day. We're almost out of time on Space Radio. But before we go, it's time for the Blue Shift. Why am I cracking myself up so much today? Greg wasn't paying attention. Thank you, Nancy, for promoting the All-Stars party. Oh, what was I going to talk about? Great questions, everyone, on the chat. I'm glad I was able to get a bunch. Momentum all the way to the top. That's right. Yeah, degaussing. You guys remember degaussing on your old computer monitors? That was the most satisfying thing in the world, right? Where you press that button, it goes, and then it comes back all crystal clear. That felt good. You're cheesy. I know I'm cheesy. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. So yesterday, I was at Miami University in Oxford, Ohio. I've never been there before. Absolutely lovely campus. Gave a seminar to the physics department there. And I talked about the language of science and science communication, because I'm kind of interested in that kind of stuff. And what I try to point out to scientists, and now I'm going to point out to you, the non-scientists, is that science speaks a different language. Science speaks a different language. Science is done. The work of science is done in mathematics. Mathematics is the language that scientists use to understand the world. This is how we do it. We don't do it with there's a lot of natural language and a lot of descriptions. I certainly had to write a bunch of papers in my life, but at the end of the day, it's all about the math, to model things, to observe things, to get the statistics, to verify. It's all done in math. Mathematics is the language of science, and it is the language of nature as viewed through science. So every time I go on the show or do an event or whatever, or write my book, I am translating the mathematics. I'm translating from another language. And just like any other translation, it's never going to be perfect. There are going to be nuances that aren't picked up. There are going to be some details missing. There'll be some things that are misinterpreted. That is the way of life. So if you're ever perplexed by a topic in science, be patient with yourself. Take your time. Realize that there's no problem. You're a very smart person. You're a very intelligent person. You just don't speak mathematics, and the mathematics especially ingrained in science. That's okay. You can be very, very smart, but just not happen to know this language. So if some concepts start to become difficult, aren't very clear, just take your time. You got to translate for a while. You got to soak in it for a while before you get there. So just be patient with yourself. If you're ever having difficulty, and then my challenge to the scientists, the academic community, is do the work of translation. Don't expect your audience to translate things for you. You got to be the ones to translate the science to them. And before I go, very, very quickly, we are taking reservations for our All-Stars party. It is a stargazing adventure in Joshua Tree National Park, which is now open and very, very clean. Don't worry, we talked to the park rangers. It's all cool. It's at the end of June. It's a long weekend in June. It's gorgeous dark skies, gorgeous area. It's domestic trip. It's pretty cheap. It's an affordable trip. Go to astrotours.co. Astrotours.co. Go to the All-Stars party. Sign up right now. We need reservations like now. Get it in. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Go to learn more at astronomy.osu.edu. The show is also brought to you by you, lovely, lovely you. Go to patreon.com/PMSutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record this show every Thursday at 4 p.m. Eastern. You can leave a voicemail on our website so you can get your voice on the air. You can also catch the YouTube and Twitch live streams. Go to spaceradioshow.com for all those links and information. You can also follow me on social media, Twitter, Facebook, Instagram. I'm at Paul Matt Sutter. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. You want me to record some promos, Greg? Just a second. And just so you know, Space Cadets, I took off my shoes, and now I'm putting my shoes back on. You didn't know. You watched this entire show, and you assumed that I had shoes on. But no, I was running around a lot today, and my feet got hot and sweaty. And I don't like the feeling of hot, sweaty feet, especially when I'm recording audio.
Oh, I knew.
Oh, you know. Yeah, he can smell it from the booth. What you got for me?
Well, we need to do a show promo and then
The ad
yep,
spot.
So take out for WCBE support for space radio.
Support. Okay. So record that. And you want to show a specific one?
Coming up this Saturday, blah, 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 blah.
Yes.
Take a blind opportunity, blah, blah, blah.
Well, why don't you just do it then? You're so good at it. Because he's not the doctor.
You are.
Okay, I got one shoe on, so I'm going to record this promo. One shoed. Unbalanced. Support for Space Radio comes from Thompson Hine, a business law firm serving clients for more than a century. Thompson Hine provides innovative client services through SmartPath, a smarter way to work, predictable, efficient, and aligned with client goals. More information about the firm at thompsonhine.com. One take wonder. That's right. Now I need a show promo, right? So I will get out my clock thingy. Okay. This is Paul Sutter, host of Space Radio here on WCBE 90.5 FM, and I have a question for you. Have you ever missed an opportunity? And by miss an opportunity, I mean you miss a robotic spacecraft on the surface of Mars that has recently shut down. I know, much more specific than you were originally thinking. For more information, tune in 2 p.m. Saturday here on WCB 90.5 FM. Can you edit that out or you want me to do it again? He can do it. Because I'm so used to in the show saying 2 p.m. Eastern, but I figured here on the broadcast, it's Eastern time zone.
We know it's Eastern time zone.
But I'm used to saying because I have a global audience. That's true, Paul Gillian. My legs have never been observed independently. You've never seen my torso and my legs in the same room at the same time. Greg, I have a present for you.
I didn't get you anything.
Of course not. Yes, I want to give you a little Valentine's Day present. I have a bunch of super adorable dinosaur stickers.
Man,
And I want you to have one.
how did you know? How did you know?
How did I know? It's because I know you, Greg. It's like I know you, like I know my own heart. Now, Would you like a pterodactyl? Now, okay, now I am aware that pterodons are not dinosaurs. They have been lumped in with the dinosaurs. I know they are reptiles. They are a different thing. Don't worry, I'm aware of that. There's also a sleeping sun. There's also like a little dinosaur like doing yoga or something. We got some trees, some very colorful dinosaur eggs, and we have, which one do you want, Greg?
Well, before I do that, one question.
Yes.
Why do you have these?
It's a present for you, Greg. Why do you, I have these so that I can give them to you. That is the reason for their existence in my hands, is so that I can give you one. That's why I have these.
Pterodactyl.
You want a pterodactyl. Do you want orange, yellow, or blue?
The orange one's really cool.
Orange one is
Yeah.
really cool.
Yeah.
All right, Greg.
You're such a giver.
I am. Where do you want? On your hand? Right there. Wear it with
Perfect.
pride. And you know
Perfect.
what I'm going to do? Check this out, because you're surprised you're my Valentine's. Whoops, I tore that one.
2?
No.
You're a
Greedy.
giver, but not so much.
Greedy. I was going to do something much more powerful.
Oh, how about that? Matching pterodactyls.
Now we got matching pterodactyls. And I'm going to wear it for the rest of the day, which is an hour and a half until I shower.
Oh, you're going to shower today?
I'm going to it's Thursday.
Special attention to the feet.
That's for sure. Thank you so much, Space Cadets. I'll see you. Yes,
Yeah.
show next week. We'll do a show next week. Don't worry. I'll see you next week.